When we think about all the amazing digital systems that run our world today, it's easy to take them for granted. But who actually designs them? Who are the real architects of the cloud? Well, in this explainer, we're going to pull back that curtain and really dig into the crucial role of the Azure Solutions Architect. So, to really get what the cloud is all about, you've got to understand the world it came from. Back in the day with on-premises servers, everything was kind of built as one giant single piece, a monolith. You designed it for a certain number of users, and that was that. And you probably used just one type of database for everything. But the cloud? Whoa, it's a completely different beast. Applications are broken down into all these little independent services that can grow or shrink on demand. And they use a whole mix of different data storage types to get the job done right. It is a fundamentally new way of thinking about how to build things. So who on earth makes sense of all this complexity? Well, that's exactly where the Azure Solutions Architect comes in. You can think of them as the digital city planners for the cloud. They're not just building one skyscraper, they're designing the whole city. The roads, the power grid, the security systems, making absolutely sure that everything works together seamlessly and reliably. Okay, so how did these architects make such huge decisions? It's definitely not just guesswork. They follow a very clear set of guiding principles. It's like having a compass that helps them navigate all the complexities and always points them toward a solid, well-designed solution. And that compass has a name, the Microsoft Azure Well-Architected Framework. It's built on 5 key pillars. First, you've got reliability, making sure your application can handle anything thrown at it. Then, of course, security, which is like putting a fortress around your data. Cost optimization is all about being smart with your money, getting the most bang for your buck. Operational excellence means automating everything you can so your team can focus on innovation. And finally, performance efficiency, making sure your app is blazing fast no matter what. A truly great design is all about finding that perfect balance between these 5. And that's really the secret sauce right there. The well-architected framework isn't some magic formula. It's a structured way of thinking. It's a checklist of questions you ask yourself to make sure you're covering all your bases. I love how John Saville puts it. This isn't rocket science. It's just good, methodical thinking. All right, think about this. Before you build a house, you have to pour the foundation, right? It's the exact same idea in the cloud. Before you write a single line of code for your application, you have to think about security and identity. Who gets in? What are they allowed to do? How do you make sure only the right people have the keys to the kingdom? To keep all this stuff organized, architects think in layers. At the very top, you have management groups. Think of this as the company's universal rulebook, setting policies for absolutely everyone. Under that, you have subscriptions, which are kind of like different departments, each with its own budget and resources. And finally, you have resource groups, which are like individual project teams, holding all the specific services they need to get their job done. This layered structure is absolutely crucial for keeping things sane at scale. One of the biggest security nightmares is storing passwords right there in your code. It's basically the digital version of leaving your house key under the front doormat. A managed identity is a much smarter way to go. Instead of you handling passwords, Azure just gives your application its very own secure identity. Then, that identity can be used to talk to other services like a database without ever having a password written down anywhere. It's a game changer for security. Let's talk about the heart of any application, its data. But here's the thing, not all data is the same. Some of it's super structured, like a perfect spreadsheet. Some is semi-structured, like a customer profile with different fields. And some is just a blob, totally unstructured, like a video or photo. A good architect knows you can't just toss all of that into one big box. You need the right kind of warehouse for each different type of good. So how do you pick the right one? Well, if your data is highly structured, maybe for a banking app, you're going to want a relational database like Azure SQL. If you're building a massive social media app that needs to work all over the globe, a NoSQL database like Cosmos DB is your best bet for that semi-structured data. And what if you're building a photo sharing service? Easy. You use something like Azure Blob Storage, which is perfect for just storing raw files like images and videos. The big takeaway here is that there's no single best database. It's always about picking the right tool for that specific job. Here's a core truth about the cloud. It's not a question of if something will fail, but when it will fail. It's just a fact. Servers crash, networks go down, whole buildings can have issues. A great architect doesn't try to prevent failure, they expect it. They design their systems to be resilient so that when something inevitably breaks, the application just shrugs it off, recovers, and keeps on running. Let's start at the most basic level. Imagine you've got just one server running your entire application. If that server goes down, well, your application is gone. It's what we call a single point of failure. It's like having only one light bulb in a huge room. When it burns out, you're in the dark. Simple as that. So the first step to making things better is to use something called a fault domain. Think of a server rack like a power strip. If you plug all your stuff into one strip and it blows a fuse, everything turns off. A smarter way is to use a few different power strips. That's basically what a fault domain is. It spreads your servers across different physical racks in the data center, so if one rack loses power or its network switch fails, your application just keeps on humming along on the other racks. But for the ultimate level of protection, you use availability zones. This is like having a powerful backup generator for your entire house. If the whole neighborhood loses power, your generator just kicks on and you don't even notice. An availability zone is like that, but for an entire data center. It's a completely separate, independent building with its own power, its own cooling, its own networking. So if one entire building has a major problem, your application just keeps running in the other one. It's about as resilient as you can get. Okay, so we've looked at all these different pieces of the puzzle: identity, data, planning for failure. Now it's time for the fun part, putting it all together. This is where the architect takes all those ideas and blueprints and actually turns them into a real, living, breathing system. Now, when you're moving an app to the cloud, you've got choices. You can rehost it, which is basically a lift and shift, like moving all your furniture to a new house without changing a thing. You can refactor it, which is kind of like renovating your kitchen. Same house, but with modern appliances. You could re-architect it, which is like adding a whole new wing to your house. Or you can just rebuild. Tear the old house down and build a brand new modern one from the ground up. The architect's job is to figure out which of these R's makes the most sense. And when you put all those principles and decisions together, you end up with a final design. Something that looks a bit like this: a baseline architecture for Azure Kubernetes Service. Now, I know it looks complicated, but it's really just a picture of all the best practices we've just been talking about. See that firewall for security? And how the workloads are spread across those availability zones for resilience? Every single piece here has a purpose, and it's all designed to create a system that is secure, reliable, and can scale to meet any demand. So after all that work, is the architect's job finally done? The answer is absolutely not. The cloud is always changing. There are new services, new features, and new best practices coming out all the time. A great architect is always learning, always adapting, and always on the lookout for a better way to build. It's a journey that never really ends, and honestly, that's what makes it so exciting.